In this video, I'm going to talk about the interesting experiment of magnetic levitation. Magnetic levitation can be classified into permanent magnetic levitation, electromagnetic induction levitation, and superconducting levitation. No matter what kind of magnetic levitation, their principle is to use the gravitational force or repulsive force between the magnetic poles to overcome the gravity, so that the object can reach the suspension. Let's start with permanent magnetic levitation. The spinning top in the video and the discs underneath are permanent magnets. This kind of magnetic levitation uses repulsive force to overcome gravity to achieve levitation. But this kind of levitation is unstable. Once the suspended object is disturbed, it's easy to lose its balance. Let's take a look at this magnetic levitation globe. There are magnets on the top and the bottom of the globe. When the globe is suspended, it would not lose its balance due to interference. That's because the coil is installed here. And the disc at the bottom is also equipped with a small element called Hall effect sensor. The Hall effect sensor can detect the magnetic field strength at the bottom of the globe and adjust the current of upper coil through the circuit. When the globe is disturbed and the gravity is greater than the attraction between the magnets, the Hall element senses the change of magnetic field of the globe and then makes the current in the upper coil increase. So the globe is always in equilibrium. This is another levitation device. There is also a Hall element in the middle of the bottom. With 4 coils, it can also prevent the suspended object from losing balance. Next, let's talk about electromagnetic induction levitation. This is the phenomenon of electromagnetic induction levitation. The ring itself has no magnetism. When the coil below is connected with high-frequency alternating current, the magnetic field in the coil will change, so that the magnetic flux in the magnetized iron core will also change. And then the induced current will be generated in the ring, and the ring will be subject to upward force. When the force is balanced with gravity, the ring will be suspended. This is also electromagnetic induction levitation. The conductor in induction magnetic levitation will produce eddy current, which makes the conductor heat. The last part, superconducting levitation. The principle of superconducting levitation is to cool the superconductor to the critical temperature, so that it has perfect diamagnetism. When there is a strong magnetic field close to it, it will produce its own magnetic field. This phenomenon is called Meissner effect. When a magnet is close to a superconductor, it can include a current inside it. Since there is no resistance in the superconductor, a large current can be generated inside it, and the current will not disappear. At this time, the rotation is almost endless because the friction of the magnets is only air resistance.